All right, so this is going to be lesson 6.2 on rational expression still, but now we're talking about multiplying and dividing polynomials. All right, so this just requires you to be able to do some factoring, and then you can cancel out, and um, that pretty much, let me see if I can focus this a little bit better. No, it doesn't look too much better, but all right, it's the best I can get on here, looks like. Maybe I can. All right, so let's start with a couple examples when we have something like this. Again, I'm going to skip a couple examples on the study guide because I don't think we need all of those. So what this is saying, when I multiply, this is something totally different than when we add and subtract. When we add and subtract, we have to get common denominators, all right? But when we multiply, we do not. So what we can do is we can cross cancel. And as long as we're canceling the numerator and the denominator, then we can cancel across or straight up and down. So I can cancel out here. 6 goes into 6 one time, and a 6 goes into 12 two times. So I can cancel those out. Well, I have 1x here, so if I divide an x out here, I have a 1, and I can divide an x out of here, and I have an x left. Then I multiply straight across. So 1 times x is x. I don't have to show the 1. And then on the bottom, 1 times 2 is 2, and that's simplified. Okay, and so this is just the multiplying, not the dividing. Okay. All right, so let's look at another example here. So how about this one? Times. All right, let's say we have this. These are from your study guide. Okay. So from here, trying to get that a little more. Okay. It's a little blurry to me, but all right. So here, so I can cancel. Now I can take this x out of here. X divided by x is 1, right? And then I can take an x out of here, so I'm still left with an x to the 1 power. Now, this has to be exactly the same, but I have an x plus y here, and then I have 2 x plus y's here. So I can cancel this, and I can cancel this, so I still have 1. So what I'm left with then is on top, I just have an x to the 1 power over a 2, I didn't cancel that out, and we have an x plus y. All right, now you want to go ahead and multiply that through on the bottom. So distribute that 2 through, 2x plus 2y. All right, so now we're going to get to where we have to do some factoring. So what I would have you do normally is have you just go ahead and pause this video after I get this written up and see if you can do this without any help, and then you can come back on and see the steps on how to do it. All right. So notice that you're going to have to factor and take out greatest common factors, but so if you want to pause it and try it, go ahead and do that. So what's going to happen here is we look here, and what is the greatest common factor there? Well, they have an x in common. So let's factor out an x. So x squared divided by x is x. 3x divided by x is 3. Okay, so I just took out a greatest common factor. Now let's look at the bottom. Okay, this has 3 terms. There's no greatest common factor that they have in common. So I know I'm going to be able to, and this is a 1, so I'm just going to be able to factor that out. So what multiplies to equal 4? Can I get a -3? Well, how about 4 and 1? And what would their signs have to be to get a -3? We would need a -4 and a +1. All right, let's look up here. Same thing, right? 3 terms, no greatest common factor. This is a 1, so I know I'm just going to be able to factor this out. So we split the x's. Factors of 4 that I can get 5. Well, it's either 1 and 4 or 2 and 2. So we know it's going to be 4 and 1 because that's how I can get 5. And I need a -5. So -4, -1. And double check when I multiply that back through, I get a +4. Okay, what about this one down here? Same thing, no greatest common factor, coefficient leading term is 1. So we split the x's. We need to multiply factors of 3 to get 2. So let's use 3 and 1. We need a positive 2, so that's going to be a positive 3 and a negative 1. So your first step is to factor everything out first. Then remember, I can cancel anything top and bottom, whether it's across or straight up and down. I just can't cancel straight across. Okay, so we have an x minus 4. We have an x minus 1. We have an x plus 3. Now, can I cancel these? No. Why? Because this is a whole factor with a plus or minus sign. So you have to cancel the whole thing. So I can't go any further. So my answer here is going to be what's left on the top, which is x, and what's left in the numerator, x plus 1. All right, that's multiplying. And we'll do some examples here in a little bit, some more examples. But so let's look at dividing. All right, so remember when we divide fractions, you take the reciprocal of the second fraction. So if I have just something like this divided by 7/16, okay, we have to make it a multiplication problem. That's how we divide fractions. So we're going to make it a multiplication, and we're going to flip always the second fraction, take the reciprocal of the second fraction. Now, if I can do any canceling like I did at the top, let's do that. So 8 goes into here once, 8 goes into here twice. I don't see anything else that will cancel. So multiply straight across, 5 times 2 over 1 times 7. All right, let's take a look at this one. Now this one will get some variables in there. Okay, so we have y for y plus 3 divided by 4y over y plus 5. So we got to flip, take the reciprocal of the second fraction. So let's leave, whoops, it's not a 4, it's a y. And some students try to flip this first one. That always stays the same. Always flip the second, and then it becomes a multiplication. So we take the reciprocal. Notice that we flip this. And then if you can cross cancel anything. Well, here, this does not have a plus or minus between it. So it's not, do you see the difference between these two? It does not. So I can cancel this y and this y because there's not a plus or minus sign between them. Now I cannot cancel these y's, right, because they have a plus or minus in there. So I don't see anything else that can cancel. So it's 1 times y plus 5. I don't really have to show the 1. And then y plus 3 times 1. Do not cancel these y's. It's incorrect. All right. Let's try another one here. We're just going to do examples on these. Okay, they just take a lot of practice. So after I write these up, if you want to practice them, and then you can get back on here and see if you did them right. You can pause me, get a break. Sometimes I write the problems down wrong. That's an issue. All right, so here we go. This is on your study guide. So what you need to recognize on this one is that this is a difference of squares and needs to be factored. And you got to look for that. Sometimes it's easy to not look for that. So perfect square, right? So we're going to have an x plus 2 and an x minus 2. Don't do anything with the denominator. Now, we're going to make that a multiplication. So we're going to take the reciprocal here. So we're going to put a negative 2x on the top, and then we'll put this on the bottom. And now it's a multiplication problem. So we can just cancel. So we can cancel these. We can cancel these, top and bottom. Can I cancel those? No, because they're both on the bottom. So I don't see anything else. I cannot cancel this x, right? Because this one has a plus. So let's just leave a negative 2x. And then we have an x plus 3, x plus 3. And you can leave your answer just like that. All right, let's go on to D here. Like I said, it's just really about getting lots of practice and doing these. So that's all we're going to do. All right, so let's take a look here. So difference of squares, right? Same as this problem up above with C. So it's an m plus 2, m minus 2, because the square root of 4 is 2. Okay, what about this bottom one? Is that a difference of squares? It is, because 1 times 1, number times itself, right? That's a perfect square. So m plus 1 and m minus 1. We're going to make it a multiplication. Now, remember we want to write the m first. I just want to show you this little bit right here. So remember, this can be written like that. And we don't want a negative leading coefficient. So let's take a negative 1 out. That makes a negative m divided by a negative 1 a positive m, and 1 divided by negative 1. That's what we want to use. We want our m to be written first, and then we have to get rid of that because we can't have a negative leading coefficient. So I'm going to move this to the top because we're dividing. So we're going to have a negative 1 on the top, and then on the bottom we have this. Well, what do we have in common here? Do we have the greatest common factor? We do. We have a 2, we have an m. So let's factor out that greatest common factor of 2m. So if I factor out a 2m squared divided by 2m, I'm left with an m plus 4m divided by 2m is 2. All right, now you can simplify however you can simplify that multiplication problem. So here's an m plus 2, an m minus 1. I don't see anything else, right? Can't do these. These are different. So what we're left with is a negative 1 times m minus 2 over a 2m times an m plus 1. And you don't have to multiply those back out, just leave it like that. That's perfect. Okay. All right. Let's move on. You know, let's do some examples. I'm going to leave a couple examples for you to try on your study guide that you can kind of do on your own. Let's take a look at the second one. I'll label this number 2 for your examples. So number 2 is a 7 minus j over 15 divided by a j minus 7 over 27. Okay. So let's figure this out here. Let's go ahead. Let's write the j first here. So if I write that, it's a negative j plus 7, right? And then we're going to take a negative 1 out of that. And that becomes a j minus 7. So let's write this as a negative 1 times j minus 7 for this right here. Okay. And then over 15. Okay, we're going to take the reciprocal. So we have 27 in the numerator and then a j minus 7. So we can cancel these. Now, is there a greatest common factor in 15 and 27? 3 maybe? Take a 3 out. So 15 divided by 3 is 5. 27 divided by 3 is 9. All right, so negative 1 times 9 is a negative 9 over 5. And you can just leave your answer like that. You don't have to write it as a mixed number. All right, let me go to the next page here. We're moving right along. All right. So how about this one? Yeah, these get a little bit bigger where you just have to do some factoring. And you guys can do the factoring. Actually, I think that's an R. Let me rewrite that again. 3r squared. So again, on this one, go ahead and shut the video off, or pause it, I mean. Don't shut it off. Pause it and see if you can get the answer. And then you come back on and see it. If I can write them correctly, 23R. All right, hopefully I have that written down right. So let's look at this example. This is number 3 examples. Okay, so this is a lot of factoring, so prepare yourselves. All right, there's not a greatest common factor, so we're going to use the AC method. Okay, so I'm going to do my work below here. Actually, maybe let's do the work over here and then I'll write it down. So we're going to start with this one. So 3R squared. Okay, we're going to use the AC method. So we have 24. We need to get 25, so we're going to use 24 and 1. And I need a negative 25, so those both have to be negative. And if I multiply them back together, we get 24, so we're good to go. So we bring down the first term, split these with this. So I have to put an R on it, remember, minus 1R. And then we bring down the last term. Split it. Okay, what do these have in common? They have a 3 and an R. So this becomes R. Negative 24R divided by 3R is a minus 8. Bring down the sign. Okay, they don't have anything in common except a 1, so you have to take something out, remember, so take out the 1. Negative 1R divided by negative 1 is R. Positive 8 divided by negative 1 is a negative 8. You really want these to be the same, otherwise it's not factorable. So let's factor out that R minus 8. If I factor that out of here, we have a 3R. And I factor that out of here, minus 1. All right, so we got this one done. So let's write it over here. We have an R minus 8 and a 3R minus 1. Okay, let's do the bottom. So here is 3R squared plus 8R minus 3. Okay, again, no greatest common factor, AC method. That becomes a negative 9. Okay, factors of 9 that give us 8, 9 and 1. We need a positive 8 and multiplied back to a negative 9. So positive 9, negative 1. Okay, so let's go with 3R squared plus 9R minus 1R minus 3, right? Replace these. Replace this with these. Grouping, because there's 4 terms, let's split it. On the left side, we have a 3R in common, greatest common factor. So 3R squared divided by 3R is R. 9R divided by 3R is 3. Bring down this sign. They don't have anything in common except 1, so we've got to take out a 1. Negative 1R divided by negative 1 is a positive R. Negative 3 divided by negative 1 is a positive 3. Which is nice, right? So we have an R plus 3 times 3R minus 1. All right, we're getting there, folks. So here's this and 3R minus 1. Now this is a multiplication, so I'm not flipping. Okay, kind of get in the habit of doing that. All right, let's go to the next one. Geez, they're all 8R squared plus 23R minus 3. Okay, gonna have to use the AC method. So this times this is a negative 24. We need a 23, so how about 24 and 1? Positive, negative, so we multiply back to negative 24 and adds to 23. So bring down the first term, split it with this, minus 1R minus 3. Okay, we have 4 terms, so we're going to group it. Over here, we'll take out an 8R. 8R squared divided by 8R is an R. 24R divided by 8R is 3. Bring out a negative 1. Negative divided by negative is an R. Negative 3 divided by negative 1 is a positive 3. Okay, so let's take out that R plus 3. And we're left with an 8R minus 1. All right, so one more. Again, we're going to have to use the AC method. Okay. So this is 24. 24 times 1. We need an 11. So how about 3 and 8? And we need a negative 11, so those both would be negative, and multiply back to a positive 24. So we're good. 24R squared in any order, minus 3R, minus 8R. Bring down the last term. let's split it. Okay, so here, what do these have in common? Well, they have a 3 and an r. So 24r squared divided by 3r, 24 divided by 3 is 8, and r squared divided by r is r. Minus 3r divided by positive 3r is a negative 1. Here we take out a negative 1, and we're left with negative 8 divided by negative 1 is a positive 8r. 1 divided by negative 1 is a negative 1. So we have an 8r minus 1 in common. When I factor that out here, we have a 3r, and factor out here, minus 1. All right. So kind of got writer's cramp on my hand. All right, so let's go ahead and cancel out anything that we can cancel out. So we have an r plus 3, a 3r minus 1, an 8r minus 1, and that's it. So what we're left with is on top, we have an r minus 8, and on the bottom, we have a 3r minus 1. All right. All right, guys, we got one more. One more, hang in there. This is our last one. I'm gonna have to kind of make some extra room here. So I want you to get that mixed up with the new. All right, so here is example 4. Again, go ahead and try this before you watch it on the video. Okay, so notice that this is a multiplication and this is a division. So we're doing a problem here that has multiple operations. So we want to go ahead and do what's in the parentheses first. That's kind of our order of operations. So we're going to go ahead and go to these brackets, and we're going to simplify this first, and then we'll come back to here. All right. So I'm just going to wait on this. We'll bring it down a little bit later. So let's go ahead and work on here. So this is going to factor to an x. Multiplies equal 9, then we can get 6. So how about a plus 3 plus 3? On the bottom, we can take out an x. They have a great, remember there's only 2 of them, so we can take out an x. And then over here, we can leave the 4x. And then let's go x multiplies equal 12, that we can get 7. How about positive 4 and positive 3? Okay. All right. So, so from there, let's simplify it if we can. So we have an x plus 3, x plus 3. Now I can cancel the x, not the 4, but that x that's on the outside. And that's about all I can do. So let's come back here. All right, so we'll bring this down, and we'll be at an x plus 3 over x plus 4 divided by, let's see what we have left here. So we have an x plus 3 on the top, and then on the bottom we have an x plus 4 and an x plus 4. Oh, and we have a 4 here. I forgot the 4. There we go. 4 times x plus 3. Okay, because we didn't cancel that out. All right, so let's go ahead and rewrite it here. So this is kind of nice because it's already been factored. So because it's a division, we got to make it a multiplication. So we're going to take the reciprocal. So we'll move this to the top, and we'll bring this to the denominator. All right, and then let's just cancel what we can. So here we can cancel this, we can cancel this, and what we're left with is an x plus 4 on the top and a 4 on the bottom. So that one looked a lot more difficult than it was. Okay. All right, so that, you guys, is section 6.2 on dividing. So I will be posting a couple assignments for you on 6.1 and 6.2 under pages, all pages. So keep an eye out for those. Due dates are, like I said, in your syllabus, so you can check the due dates on it as well. All right. All right, you guys, have a great day.